Good evening, students. I welcome you all to the video lecture of Advanced Microprocessor and Microcontroller. We were discussing 8051 instruction set, and in this series, we have discussed 8051 addressing mode. Then we have taken up the instruction set of 8051, in which we discussed arithmetic instruction, logical instructions, data transfer instructions, and now it is the time to discuss bit manipulation instructions. So when we talk about bit manipulation instructions, say for example, I am talking about program status word. We know that program status word is basically 8 bit. That is PSW 0.0 to लेकर PSW 0.7, PSW 7.7, PSW 0.7. So this basically points to each and individual bit of program status word. When we want to manipulate a single bit of a register, it is called as bit manipulation instruction. Say for example, clear C. Here we want to clear the carry flag. Set B. We want to set the carry flag equal to 1. Complement C. We want to complement the value of C. And ANL. That is, we want to use a AND gate for a specific bit. That is, carry needs to be AND with a specific bit. This specific bit can be of any register. Similarly, ORL. We want to use the OR gate for a specific bit and a carry. Similarly, we can use move instruction as well, but here the move command is used with some sort of a bit. That is bit comma C. That is, we want to move the carry flag in a specific bit. So this is all about the bit manipulation instructions. So the next is program and machine control instruction. As in the case of 8085 and 8086, we were using transfer of control instruction in the form of interrupt, or you can say in the form of call. We know that there is a command of 8085 that is call subroutine. Similarly, in case of 8051, there is a provision of call subroutine. There is a provision of jump. Jump can be conditional, jump can be unconditional. When we attribute jump with some sort of condition, it is called as conditional jump. And when there is simple jump, it is called as unconditional jump. Again, the jump can be absolute, jump can be long, jump can be short, or a simple jump. So here A call is the absolute call, L call is the long subroutine call. It is used for call instruction. Return is return from subroutine. RETI is return from interrupt. There is absolute jump, there is long jump, and there is short jump. There is a classification between these two jumps. I will take up this part subsequently. Jump is unconditional jump. JZ is conditional jump. Similarly, there is another command that is CGNE, that is compare. Say for example, I am taking CJNE A comma 20H. Here 20H is the data. Here the contents of A and 20H is being scrutinized and tested. And if after comparison there is a condition that the value of A is equal to 20H, then jump to some specific location. Similarly, we can use DJNZ R1 comma 20H. Again, decrement the value of R1 and jump if not equal to 0 to a specific address. NOP stands for no operation. NOP stands for no operation. Now, we were using the term long jump, absolute jump, short jump. When we use the term long jump, the destination of long jump is for a call or a jump instruction 64 kilobyte of program memory. For an absolute jump, it is within the 2 kilobyte of memory. For a short jump, it is between from plus 127 to minus 28 bytes related to the first byte of the next instruction for a short jump. I hope you will like this video lecture, and this completes the instruction set of 8051. So I request you to take these 3 video lectures into your cognizance and try to work at your own end, taking various e-learning material or instruction set into account and develop your understanding. If you have any sort of doubt or any sort of problem, feel free to talk to me. Thank you. Thank you very much.